Welcome to Minefield! From UpTooLate, we have this brilliant rendition. It is so much fun. You can select hard, medium, easy, reset the world. You got color pickers. When you press the trigger finger, it'll switch between blue and red to mark for bombs, blue to see if it's safe. Oh, it wasn't safe on my first go! This game is a lot of fun, especially in VR. Thank you so much for inviting me to help on this UpTooLate. Really appreciate it. Absolute pleasure. Let's start by talking in general about how this was made, because really today I just want to talk about the math. Math can be so much fun, and today is no different. As you can see, we have the 30 bombs down here, and depending on what level you place, either 10, 20, or all 30 bombs will be placed randomly under this field. And so you'll see them placed under here, and they're invisible so you can't see where they're at. But now as you go about clicking up here, these triggers go off, and these triggers have counted the number of bombs within a radius of them, and then that determines the number. You can actually check this out right now. We're gonna have it in beta. Come on by, play some Minefield. What I've done is I've created a random number that is calculated based on the number of bombs. So we have 100 squares. This is a 10 by 10 grid. And we know that we're going to have either 10, 20, or 30 bombs. What we can do then is take these 10 bombs, divide it by 100, leaving you with 1 bomb per 10 spaces. So to get this working correctly, we need to have a random value. We multiply that by 2, and we get a random number between 0 and 20. But we know on average, it's going to work out to be about 100. Because our random number starts between 1 and 20, 10, or about 6, we then know that this 0 space will never have a bomb, or will it? Well, when the bombs actually get over 100, so if the numbers happen to be larger, we place a bomb here in the 00 slot, and any subsequent bombs, so if it's really a bunch of large numbers one after the other, will be left remaining. It's very rare that that could happen, but that is the only instance where you might not see exactly 10, 20, or 30 bombs total in the minefield. So that is awesome. But how do we get it to place in a grid like this? Because if we're just taking that random number and then we add that additional random number, so say the first random number is 9 and the second random number is 8. 9 plus 8 is going to be 17. Well, if we take 17 and we divide it by 10, so we divide it by the length of the row or the length of the column, we then know that the position on the row value, so we know that 17 comes here to the second row, and it comes over by 7 because we're left with a remainder of 7. So what we're using is the same method that we used for creating timers, which is to create a floor. So you take your 17, you divide it by 10, and then you calculate the floor of that, and you're left with 1. And so floor is found under your operators tab under math, and you can use that to get the value without decimal. Then after we know which row it's in, we can multiply by 10 and subtract from the original value of 17 to get 7, so our remainder represents the column position. So you can do that for any number between 1 and 100, and then we use an if statement to say if it's over 100, set the value back to 0 and stop running the while loop. For counting the number of bombs between like this one here, what we do is we say on this trigger, we move the relative position of the trigger down by 0.6 to be here. And then we calculate the distance to, using a while loop, to every single bomb. And so if the bomb is within 1.6 meters, we know that it is within the radius of that block. So then we can count and add to 1, 2, 3, 4. So we know this value on this block will be 4. And we can do that for every single one of these. And to make this really simple, this first trigger here is the control trigger. And because this is the control, I have a Boolean that says I am control. So on the control object, I press that, and it's the only one that runs a bunch of code a single time. So I use an if statement to say, if you're the controller, then you can run these initializing codes. And then every other object is a duplicate, but it's saying I am not the controller. And so we just duplicate this across the whole array. And if there's any other changes I need to make to the entire series, what I'll do is I'll delete all of the triggers, all 99 of them, and then I will make the change to the control trigger, duplicate it one time, and then I'll make the change to say it's not the controller. Then I duplicate it twice, then 4, and then 8. By selecting, I can continue duplicating, and it makes it really easy to fill out this entire board. As we can see, UpTooLate is demonstrating how to find bombs. This script is at an unbelievable 82% capacity, so we're not going to go through it with a fine-tooth comb, but I want to talk about some really unique things that are going on in here, like this if not controller. When it's not the controller, we listen to a singular event on the controller, which is awesome. So we connect to that control object, and then when the initiate bomb starts, we start running over here. But if it is the controller, we send delayed start first. Another really cool trick is we're using the distance to the control object from self and dividing it by 2 to determine how much time it takes before it initializes itself, because in its initialize command, it goes through all 30 bombs. And so we have all 30 bombs tied in here, and then it goes through and says how far am I away from each of these bombs, so having a delay between that is really important. And here's that bomb initiation while loop. We start by setting the iterator to be the length of the bomb list, and while that iterator is greater than 20, we then do our while loop. And the reason we're running it with 20, not 0, is because when we initially had this set to 0, we were getting all sorts of errors, half the bombs weren't spawning in, and so it turned out we needed to break the while loop into 3 segments, and this worked great because we were able to use the easy, medium, and hard to define those segments and only send the medium and hard bombs if it's in medium and hard mode. And so while the iterator was greater than 20, we set the iterator to be -1, and then we set the current grid position. This is a variable that starts at 0 and goes to the maximum of 100, as we have 100 grid positions. So we set it to start from 0 to be 0 plus a random number between 1, and then we take the number of grid positions, so 100, we divide that by the number of bombs, and then we multiply it by 2. This creates an average of 100. And if the current grid position is greater than 100, then we set the iterator to be 0 and we set the grid position to be 0. This stops it in its tracks, preventing it from going any further, and makes the last bomb go to the 0, 0 position. We then set row to be the floor of current grid position divided by 10. So remember how I was talking about the floor allows us to get a whole value. So we take the current grid position, we divide it by 10, and we know which row is it in. So we set the row to be either 1 through 10, and then we set the column to be the current grid position minus the row times 10. So now we have the row and column set as variables. We don't want these bombs to be seen, so we start by hiding that item from the list, so we get the iterator value from the bomb list. And then we move to, and remember, this whole initiate script is only running on the control object, so the control object stays in place. So we're using that position, plus we're creating a new vector from XYZ, and then we take number -1 times the column, and so this -1 allows us to flip the orientation of our column value, because the column value is a whole number, and then we multiply it by grid scale, because this grid is not exactly 1 meter, it's 1.05 meters, so we multiply it by 1.05, and then we know that we want the bombs to be -0.6 below the grid, so we move it 0.6 down, and we take the row and multiply it by grid scale, which happened to be right in line, and it was already in order, so no need to multiply by -1. We then move this on the item from the list, which is that bomb. And we continue doing this while loop for all of those bombs. And then when we're done with that, if the number of bombs is greater than 19, we send initialize part 2, and so we run part 2, and then we can run part 3 after that. Everything in the next set of while loops is the same, except for we use the number 10 and then the number 0. To determine how many bombs are near, we have to run this after the bombs have been placed. We then set iterator to be the length of the bomb list, and while the iterator is greater than 0, so it's going to run through the entire list of bombs, we set iterator to iterator -1, updating the list every time the while loop goes through. We then get the distance from my position to the position of the bomb from the list, so whatever bomb we're at, so the iterator gives us our bomb value. And if it's less than 1.6, we know that it's within a radius that we want to count it. So we set the bombs near me to be bombs near me +1, so we add 1 to that list. And then if distance from my position to the position of that bomb is less than 0.6, we know we're on a bomb. We're sitting on a bomb, that's bad. So we set I am bomb to be true. So that's a Boolean that we set to be true. And if I am bomb, we set bombs near me to be -1, because we're going to use this bombs near me value later to determine what happens when the blue stick enters the trigger. When the stick enters the trigger, we send event what color to that stick. So we need to know what color is the stick currently at. We send it with the variable self, so that way it can send the event right back to us with the color. So when what color is received, we get am blue. So what color goes out to the object and it comes back with the Boolean I am blue. So then if I am blue, we check the bombs near me count, and if it's 0, 1, 2, or greater than 2, we then change the color on the text object to represent how dangerous that text object is. After that, we display the number of bombs on the text object. And the reason we have to run this next if statement after all of that is because if it is a bomb, we find out it's -1. And when bombs near me is -1, things go boom! So when we know it's a bomb, we set it to a deep red on the text object. We display boom on the text. We play the boom sound effect 1 and 2. We move to the position of self on the bomb visual effect. We play the bomb visual effect, and we send event delayed reset to self with 2-second delay, so there's time for the effects to go off before resetting the world. And then here in the delayed reset event, you'll see that we reset the world state. If I am not blue, meaning the stick is red, we mark it with a deep red on the text object, and we display X, meaning this is a bomb. I do not want to accidentally set it off with the blue stick. And that's how we did it. If you have any questions, don't hesitate to ask. Absolute pleasure, UpTooLate. Super excited to play this game with everyone. Let's go see how long we can survive for. Wow, this is really hard. Where's a safe space? Oh, I found a 0. We're good. No, you lost! Thank you guys so much for joining us. We look forward to seeing you here in Minefield. And if you haven't already, please subscribe. Bye!